Okay, this is the lecture video for Mac 1140 Pre-Calculus. We're in section 10.2, continuing with our study of parabolas. We're on example 7. Okay, so in this problem, it asks you to find the equation of the parabola described, find 2 points that define the latus rectum, and graph the equation. They start you off with information that's going to allow you to determine which way it opens so that you can write the equation of the parabola. So we have a point that's at 0, 0, and the axis of symmetry this time is given, and it contains the point 2, 6. Oh no, it's read like this. Vertex at 0, 0. Axis of symmetry, the y-axis. And then the parabola itself contains the point 2, 6. Okay, so got that down. So now 2, 6 is right here. Okay, so you have it going through this point. The parabola contains this point right here, 2, 6, and then it has this vertex. And if the y-axis is acting as the axis of symmetry, then you have symmetrical points on either side of the y-axis. So if you have a point that is 2 units over and 6 units up in the air, you have the same sort of point going in the opposite direction. 2 units to the left, 6 units up. So you could feed that information right into MyLab Math in order to get the graph. You can give these 2 points, one on either side rather than the lattice points that we used in the last problem, and you can put the vertex in there, but you can also use the lattice points. Okay, this allows us, by way of the information that they started us with, to know what kind of equation it is. This would be an equation with vertex at the origin, so it is not shifted. So we won't be using the shifted equations, but we'll be using the ones that are non-shifted. And when it's opening either up or down, it would be the x squared equation, and specifically, since it's opening up, that 4a coefficient on your linear term is going to be positive. Okay, so you have x squared for any kind of a vertical parabola. The 4a coefficient is positive when it opens up rather than down, and that is the coefficient of the linear term. Okay, so that's what we're going to be plugging into. We now have to figure out what the a value is. The a value can be calculated by knowing what the distance is from vertex to focus, or from going from vertex to the directrix. So what we're going to do in this particular case is we're going to say that we can use this information that has been given as a way to get to the a value. So always what they start you with is a way to get to the a value so that you can eventually get the 2a value and get the 2 lattice points. So notice that we know the equation is of this form right here, and we don't know the focus and we don't know the directrix. So what we could do is plug this in as x and this in as y, leaving us with nothing but the a value in order to finish this equation, because they don't want us to just leave it in formula format. They want us to have an actual value here, not just a. So we can put 2 in for x. This formula says square it. And then we can go 4 times a times the y partner. That goes with 2, which is 6. So we have 4 is equal to 4 times 6 is 24a. Continuing up here, I would take this equation. I'm just going to copy it up here again so I can show you what I'm doing. I'm going to divide by 24 on this side, divide by 24 on this side, and I end up with a is equal to 1/6. Okay, if the a value is equal to 1/6, then I can finish this equation. I can go x squared and give a more exact equation is equal to 4 times a. My a value is 1/6, and that is the coefficient of my linear term. So 4 is the same thing as 4 over 1, so top times top, bottom times bottom is 4/6y. but reduce it, of course, if possible. And that is your finished equation in order to answer this question. What is the equation of the parabola? When you're feeding this into MyMathLab, that y can be written out to the side or as part of the numerator. Don't dip it below the fraction bar. Okay, so now we know what the equation is and what the a value is. Remember that the value associated with the lattice points is 2a. So if a is equal to 1/6, then 2a is equal to 2 times 1/6, which is 2 over 6 is 1/3 when you reduce it. That's your 2a value. And you're always thinking of these values in their positive sense. Okay, so now let's see. If we're going to find the lattice points, seeing that the focus, let's see the focus. Okay, we're going to go to the focus points. So we're going to start from this vertex right here. And I want you to look at the picture, because if the vertex is right here, then the focus has to be up in here. Let me make this a little bit bigger so I can at least draw some points in here. Okay, so the focus has to be inside the parabola. So knowing that each time that you draw these parabolas, that indicates that you have to move up. And if you're going to move up, that means you're going to be adding that distance of A, which is equal to 1/6. You're going to be adding that 1/6 to the y coordinate just to get upwards. So now this is very close to the vertex. The focus could be said to be right there. That's why I wanted to make it a little bit wider. I can't fit any numbers in there, but I just wanted to give you a visual on where the focus is. It is 1/6 of a distance away from the vertex, but lined up with the vertex. So let's state that our vertex is at 0, 0. We were given that information. And we'll even label it. And we're going to be going up from this vertex in order to get to the focus. When you're going up, the only thing that impacts is the y coordinate. So it's going to be from vertex to focus is always a distance of A added on to whatever the vertex is. And I'm adding it to the y as opposed to the x because I'm moving upward. So my A value was 1/6, and the y coordinate that I'm adding it to is 0. So just showing you how I got this answer. Leave the x value alone. So that's your focus. Now I really wanted to answer what the lattice points were, the one to the right and the one to the left, but I couldn't do that unless I had the focus. So after you find this focus here, start from the focus. See, that's why you have to have a good understanding of where everything is situated. The focus and the vertex are aligned. They are collinear. And so is the focus and the lattice points. One lattice point would be out this way to the right. I'll call it L prime. And the other one would be right here to the left. So it says the left point. Let's find the left point. Let's start at the focus, which is 0, 1/6. And let's go to the left. Anytime you're going to go to the left, you are impacting your x coordinate. So it would be the x coordinate, the way that the focus and the lattice points are connected, so we'll call this the left lattice point. The way that they are related is that the focus and the lattice points have a distance of 2a in between them. Because I'm moving left, you subtract. When you're moving to the right, you add. And you're adding that 2a value, which I'll put down here. So it is the x coordinate minus 2 times a. We said that was 1/3. We have it written up here. So my left lattice point, 0 take away 1/3, negative 1/3. Moving left, you are not impacting your y coordinate, so leave it as is. For my right lattice point, For the right lattice point, you're moving to the right, therefore you're adding. So you take your x coordinate and you add that to a value. That's why you should calculate the 2a value as soon as you know what a is, so that you can do other things with it, like finding the lattice points. So this is going to be 0 plus 1/3. 1/3. Leave that y coordinate alone, because all you're doing is moving to the right. You're not moving up and down. If you were moving up or down from the focus, then your y coordinate would change. Okay, so you have two answers. The left lattice point is at, let's highlight these. So this is my left lattice point right here, and then this is my right lattice point. Get them in the right spot, because my math lab will mark it wrong. So left lattice point is -1/3 and 1/6, and then the right lattice point is 1/3, and list them in a point as a point using the proper symbols and everything. And those are your two lattice points, and there's the graph. So we wrote the equation, we got the lattice points, and we also have a nice graph of perfect width, because we had a leg, two symmetrical points on either leg. Okay, moving to number 8. In problem number 8, it says find the equation of the parabola described below. Find the 2 points that define the lattice rectum. So we need the 2 lattice points, and graph the equation. But this time, they start us with the vertex and the focus, and the distance between these two things is A. So we're going to do, but now notice that our vertex is no longer at the center. So when we go to write our equations, we're using those shifted equations. This is shifted 4 to the right and 7 down from the origin. So we're going to go 4 all the way down to 7. This is 4, 5, 6, 7 right here. Line that up with 4, and you have the vertex. Okay, now let's see which way this opens. Let's see. We're going to be able to tell right now by putting the focus. So the focus is at 4, -9. So remember something. The focus has to be inside the parabola. So the only way that this focus could be inside of the parabola is, and remember, you're opening from the vertex. That's where the parabola starts. So if you're going to wrap around that focus so that it's inside the parabola, that means this must open downward. This has to be a downward parabola. Further, try to understand that the distance between here and here is your A value. This one's at -7. And this one's at -9. That is the difference in the distance. So your A value, thought of as a distance, which means you should think of it as a positive number, is 2. Your 2A value, which we'll need when we go to find the lattice points, is just 2 times this. 4. Okay, so we have our A value, our 2A value. We know which direction this opens in, so now we can do the equation. So again, being that this vertex is no longer at the origin, we'll use the shifted equations. When you're opening either up or down, you are having your square on your x expression and your linear expression. Your first degree expression will be the y. Okay, so here is the shifted formula for a vertical parabola that opens downward. This speaks to the fact that there is a shift away from the origin, and the shift is this h and the k are the coordinates at the vertex. Then because it opens down rather than up, that coefficient of 4a is negative, and then you have your linear term. K is always with the y, h is always with the x. And the h and the k that you need to supply to this equation are the coordinates at the vertex. So this is 4, as you can see they gave you, and this is -7. So to refine this equation, it would be x minus 4 squared minus 4 times your A value, and we're going to look for that A value, or we already have it. There it was down there. The vertex was at 4, -7, while this one was at 4, -9. So there is a distance in between of 2 units. So we can actually come right back up here and plug that in for A. And then it's y minus the k coordinate, which is the shift on the y value at the vertex. And that was -7. So put that in right here. The signs that these two coordinates use when you're in the graphing mode are the opposite of what they look like when you plug them into the equation. See here, this looks like a +4. When you look at the equation, it looks as though it's a -4. And this is going to be, let me continue refining this. This is x minus 4 squared. You have a -8 out front. -4 times the A value ended up being -8. And then you have y plus 7. See how that 7 appears to be positive, but when you pluck it out of the equation for graphing purposes and list it as a point, it has the opposite sign. Okay, so we have the equation. Did some analysis by plotting the vertex and plotting the focus to help us find the A value. That gave us this. The fact that it was shifted made me use this equation. And because it opens down, I used a -4A value rather than a +4A value. So I think all that's left now is to find the 2 points that define the lattice rectum. Now they don't ask you left and right, they just ask you for both of them. So give both of them, separate them by a comma. However, let's look at the picture to try and see which way do we move from the focus in order to get to the lattice points. I'm going to remove this. I'll put it out here to the side that A distance was 2. Okay, so the lattice points determine how wide the legs on the parabola flare out. So if you're here at the focus, you want to know how far should I flare to the right, how far should I flare to the left. So you're moving in a sideways manner when you try to plot the lattice points. So you want to start by recognizing what are the coordinates of the focus. Well, the focus was given. It was given as 4, -9, and you want to move to this is where just plotting these 2 points is going to help you. The parabola opens from the vertex, wraps around the focus, but you need to know how far right to flare this leg, how far left to open this other leg. And so that is a right and left movement. Okay, so again, the relationship that you need to memorize is that when you're relating the focus to any kind of a lattice point, it's a distance of 2A. Because I'm moving to the right, that's going to impact my x-coordinate. Movement to the right or left impacts your x-coordinate. When you move right, you add. And specifically, I will be taking my x-coordinate and adding, let's see, what was our A value? We determined that our A value, we just counted it with our fingers, was 2. Always want to think about that in a positive sense. And therefore 2A, well, I think I already said this down at the bottom of the page, but I'm writing it again. So 2A is equal to 4. So I'm going to be actually taking that x-coordinate and adding 4 to give me my right lattice point. Okay, so 4 added to the x-coordinate is 8. Leave the y-coordinate alone. Then I want to move to the right. To the left, sorry. We already moved to the right. So when we move to the left, we're going to subtract that distance of 2A. Again, that 2A value is 4. So if you take the x-coordinate you have and subtract 4, you end up with 0. Leaving the y-coordinate -9, because we're only moving left and right, not up and down. Okay, and this represents my left lattice point. And if you want to have a nice full graph and that you'd be able to fill in the points that my MATLAB is going to be asking you. You could give it the vertex. You want to give it points that are actually on the parabola. The focus is not on the parabola, it's inside of it. So you need to give it to either two symmetrical points like we did in the last problem, or give it two lattice points. Most of these problems involve you giving it two lattice points. So it would be 0, -9 is one of them. And then the other lattice point was 8, -9. Okay, and then you can plot those as well. Just go to 0, -9, that's one of them, and then the other one is 8, -9. All lined up with the focus to give you perfect symmetry on that parabola. Okay, and there's the graph. Okay, so we had our equation, our lattice points, we figured out our A value, and then we also graphed it. Okay, moving on to number 9. In problem number 9, it says, find the equation of the parabola described below. Find the 2 points that define the lattice and graph the equation. So this time we're given a focus and a directrix. So the focus is at -3, 7. 1, 2, 3, 4, 5, 6, 7. Okay, you might want to label that so you can figure out, hey, is it 2A that I'm working with? Or is it A that I'm working with? All my pencils are breaking. Okay, that's the focus. Okay, the other thing is the directrix that you're being given, and that is at y equal to 5. So y equal to 5, anytime you're talking about y equal to anything, that is a horizontal line. Okay, so let's see, y equal to 5 would be right here. Remember that the directrix is on the outside of the parabola. So right here, by knowing where the directrix is and knowing where the focal point is, and the fact that the parabola must wrap around the focus and it may not come in contact with the directrix, therefore this has to open upward. Okay, the vertex has to be halfway between the focus and the directrix. So if this is right here, let me try and make this a little bit smaller. If this is at -3, 7, then the vertex has to be right there. Okay, you can see that the distance from here to here is just 1 unit, so that you have equal distances from vertex to focus as you do from vertex to the directrix. This distance from focus to directrix is 2A, but vertex to focus, 1 unit. Vertex to the directrix, 1 unit. These are the same distance right here. So A is actually 1 in this problem, and 2A is equal to 2. Okay, so now let's go further with that, and we're going to write the equation of the parabola. Okay, so as I was stating, open from the vertex and you're wrapping around the focus. Therefore, this has to open upward. Notice that this vertex is not at the origin. Therefore, you're using the shifted equations. Okay, the equations here for number 9, since it opens upward, that is a vertical parabola, and anytime you open either up or down, the square is on the x expression. So we're going to start by recognizing that this would be the formula that we're plugging into for an upward parabola. The 4a expression is going to be positive because it opens upward rather than downward. Okay, don't forget h and k is -3 and 7. Okay, so as we continue to plug in for this, this is going to be x minus the -3, the h coordinate, squared, and then 4 times the A value. We said A is equal to 1. And then we're going to go y minus the k value, which is 7. Continuing with that, cleaning it up a bit, we have a double negative. So it's going to be x plus 3 squared. 4 times 1 is 4, and then we have y minus 7. Okay. All right, so now continuing with this problem, now we're going to find the lattice points. So far all we have is the equation. And let's play off of the picture again in order to figure out, hey, which way do I move from the focus to get to these lattice points right here? You need a visual to help you get focused there. Okay, let's see. If I was going to graph this without any consideration of how wide it is, I would just open from the vertex and go shoop, left and right. Therefore, you have one leg to the right, one leg to the left, but we want to know how far right should I flare this leg, how far left should I flare that leg, and it is the lattice points that control that. So you're going to be moving a certain distance this way and a certain distance this way. That distance is defined by the 2A value. That is the relationship between the focus and the lattice points. Okay, so we're going to start with the focus, and the focus is at -3, 7. And then we're going to go to the right and to the left, which means we're impacting the x value by a value of 2a. So a was 1, 2a was 2. Okay, so we're going to go this x value right here, -3, with 2 added to it. That would take us to -1, and then there would be a 7 right here. Okay, then if we're going to go to the left, we're going to be subtracting 2a, which means we're going to take the x value and subtract the 2a distance, which again is 2. Just like it's 2 here, it's 2 here, only we're moving to the left. So my left lattice point is going to be -3. That's the x value, take away 2. So that's going to be -5, 7. Okay, so we have our 2 lattice points. And then once we plot them, we could actually finish this graph. Left lattice point, right lattice point. Okay, so those are our 2 lattice points. And then finish the graph. Okay, so if we plot -5, 7, this will be -5, and then get right up there to where the focal point is. I have to erase some of this so I can complete this graph. Okay, you might want to keep this labeled. I just want to move it over. That's your focal point, because you want to make sure that when you're plotting these lattice points that you line up with the focal point. So you're supposed to be at -5 and then up at a height of 7, just like the focus is up at a height of 7. Then the other point is -1, again up to a height of 7. Whoops, I should be at -1. So -1 right here, and then up to a height of 7, you should be right there. So we have the focus in the middle, lattice point to the right, -1, 7, lattice point to the left of the focus, -5, 7. Now connect from your vertex through these lattice points. That's one lattice point there, and then here's the vertex right through the other lattice point, and there's the graph. Okay, moving to number 10. And problem number 10. Let's see what they start us with this time. If I can separate these pages. All right, so in example 10, they give you the equation already. So the equation's already done, and you're going to find the vertex, the focus, and the directrix. Okay, so vertex, when it's in this form right here, you can just pull the numbers right out of these parentheses. The number with The x will represent h, but the way they look in equation form, they look as though they have the opposite signs as when you're going to graph them. So when you pull this out, h is really -4, but it'll always be hanging around with the x in the same parenthesis. This is the k value because the formula goes x minus h, y minus k. And those minuses are why we switch them as we're taking them out. So this would be +1. Okay, that represents the vertex. Okay, the focus. Let's go ahead and put these things on the graph as we find them. So this is going to be -4, +1. And I'll just label that is my vertex. Okay, so now also what I can get from this equation not only gives me h and k, but it also, I'm seeing this coefficient of the linear term, and that always represents the 4a value. So that this would mean 4a is equal to 8, and if you divide by 4 on both sides, you get a is equal to 2. Okay, so the focus and the vertex are separated by a value of a. So you can go, you're at this -4, 1. Okay, and now look at how this thing opens up, because we have to kind of get ourselves visually focused here so that we know which way to move from the vertex. I mean, yes, the vertex and the focus are separated by a distance of 2, but should I go 2 this way, 2 this way, 2 up, 2 down? So you have to get a sense of which way does it open up. Well, the equation tells you this. When there is a square on the y and the 4a value is positive, that means it opens like this. Square on the y, 4a value is positive. Those two things combined means that it opens to the right and that it that it's a sideways parabola. I'm saying the same thing. Okay, so the focus is going to be this way because you have to go from the vertex, open up the legs on the parabola, wrapping around the focus. Therefore, I am going to be moving from vertex to focus. I'm going to be moving to the right. Okay, so take that vertex of -4, 1, and I'm going to move to the right. Again, the distance between them is a. Okay, so I'm going to be I'm moving to the right. That impacts my x coordinate, and I'm going to move specifically a units, and a was 2. So it's -4 plus 2, -2, 1. And that represents my focus. Okay, so -2, 1, there we go, with the focus all lined up with the vertex. Then if I'm going to try and get the full parabola with the directrix, let's see. They haven't asked me for the lattice points, but it does determine the width, and they're going to ask you for more than just a vertex, and you can't feed the focus in. The focus is not on the parabola, it's inside the parabola. So I'm going to go ahead and do those lattice points anyway. Okay, if I'm going to try and do a lattice point with respect to this focus, that means it's going to be up here somewhere. I'm going to have to move up from my focus, which is -2, 1. I'm going to have to move up, and I'm going to have to move down from the focus because they're all lined up. There's one lattice up here, one lattice there, which determines the width. So if I'm going to move up, that means I'm going y plus, okay, relationship between focus and lattice points is 2a. So I'm going to be adding 2a here, while when I go down, I'm going to be subtracting 2a. So this is going to be -2. And then think about what that 2a value was. A was 2. Therefore, 2a is equal to 4. So it's 4 that I'm going to be adding whether I go up or down on my y-coordinate. So here I'll be going y minus 4. Here I'll be going y plus 4 to get these points. So my upper lattice point is going to be, take that y value and add 4. You're going to have 5 while leaving the x as is. Take that y value and subtract 4, and you're going to have negative 3 while leaving the x value up is. So this is upper lattice point above the focus, and then the lower lattice point would be negative 2, negative 3 below the focus. Okay, and go ahead and plot those. So this is negative 2, 4, 5. That's one of your lattice points. Connect right through there. And then the lower lattice point is at negative 2, negative 3. So there is the parabola with the width defined by the lattice points, and then the directrix is on the outside of the parabola. Whatever the distance is from here to here, which is 2, you're going to move that same distance but to the outside. So this is 1, 2 units back this way. This would be the directrix. It cannot interfere or intersect with the parabola. Lines that run up and down like this are called x is equal to, and the number that they run through, which is negative 6. Okay, we now have everything required: vertex, focus, directrix, and a graph. Okay, moving on to number 11. Okay, at number 11 it says find the vertex, focus, and directrix. Okay, so again, they're being started in the same way that you were started in example number 10. They're giving you information that will allow you to get the vertex, because it's always x minus h squared, and then this right here is the 4a value, this negative 1 that you're seeing right here, and then this expression is always y minus k. So we can say that our vertex, which is always h and k, okay, opposite of that, negative 2. Opposite of this, negative 1. Okay, then that 4a value is always the coefficient of the linear term, happens to be negative 1. So divide by 4, and you would have negative 1/4. However, I've been saying that a really represents a distance, so you want to be able to think of it in its positive sense. Okay, that just makes this negative go away. As you're figuring out other points that are associated with this graph, you want to think of this as a distance. That's what absolute value means, the distance of the number. Okay, so the vertex was negative 2, negative 1. And then when you're looking for the focus, you might want to see what's on the graph. Go and put the point on there, the vertex, which is negative 2, negative 1. So that's your vertex. That tells us that we're going to open from there, but it doesn't tell us the direction. But now we can look at the equation to tell what's going on. Square on the x is a vertical parabola, meaning it opens either up or down. So go look at your 4a value. Whenever you have a square on your x expression and the 4a value is negative, these kind of parabolas can open up or down, but because the 4a value is negative, that means it opens down. Therefore, the vertex with respect to the vertex and the focus would be down because you're supposed to be wrapping from your vertex around the focus. And you'd be going that many units. So I'm going to stop the video here. I'm going to finish this. Let me just finish this comment that I was making, that your vertex is at negative 2, negative 1. And if you're going to wrap around the focus, then you should be moving down from the vertex in order to get to the focus. And you would, if you're going to be moving down, that means you're impacting your y coordinate. So moving down means taking the y coordinate. It's always a value of A that separates, a distance of A that separates the vertex and the focus. So you'd be subtracting the A value. So in this particular case, it would be -1. The actual A value is 1/4. And you can get your calculator to help out with that. So leave the X as is, and then go -1 minus 1/4. Take that Y value of -1 and go minus 1/4. -1 minus 1 divided by 4. And to get your calculator to do all that for you, just hit Math, enter twice, and you have -5/4. Okay, I'm going to stop there because I'm running out of video space here, and I'm going to pick up with this problem number 11, in the next video.